So we have already know which water source should be selected as our drinking water source. But before those water from the water source coming to the pipe in our home, there are still processes that we need to do. First of all, it's the purification of drinking water. So what is water purification? Water purification is the process of removing all kinds of contaminants and pollutants from our drinking water. Water purification is a simple way of removing or reducing anything that we do not want in our water, whether it's one contaminant or many contaminants. The goal of water purification is to remove unwanted constituents in the water and make it safe to drink or to fit for a specific purpose in industry or medical applications. There are many different kinds of techniques available to remove contaminants like fine solids, microorganisms, and some dissolved inorganic and organic compounds or materials. So in detail, the purification process including 4 steps. The first one is coagulation and flocculation. The second one is sedimentation. The third one is filtration. And the last one is disinfection. First of all, let's look at the first one, coagulation and flocculation. Coagulation and flocculation are the first steps in most conventional water purification processes. It is the addition of chemicals to assist the removal of particles suspended in water. First of all, coagulation is by the addition of inorganic coagulants such as aluminum sulfate, aluminum or iron chloride to cause several simultaneous chemical and physical interactions among the particles. So during this process, negative charges on those particles are neutralized by those inorganic coagulants. And then during the flocculation process, those precipitates they will combine into larger particles under the natural processes and sometimes by induced mixing, which is referred to as flocculation, and facilitate the removal of particles by subsequent processes such as sedimentation and filtration. So coagulation is by the addition of those coagulants such as aluminum to form with the particles to form little precipitants, and then flocculation is to assist the combination of those small precipitants to larger particles. As we can see from this picture again, coagulants such as aluminum or aluminum sulfate are added, and then impurities will be trapped in those precipitate forms by the coagulants. And then by the little mixing or stirring called flocculation, yes, the precipitates will be settled to the bottom and then can be removed by sedimentation and filtration. So the second step is called sedimentation. Sedimentation is a physical water treatment process using gravity to remove suspended solids from water. Solid particles entrained by the turbulence of moving water may be removed naturally by sedimentation in the still water of lakes and oceans. This is very easy to understand, right? Because the suspended solids, sometimes they are heavier, so by the gravity, they will slowly go down to the bottom of the water body, especially in the still water. The still water means the water is not moving, not floating very fast. We can also see from this picture, the water containing insoluble impurities are seen in the left, and then we can see that after some time, during the sedimentation process, the insoluble impurities will be settled at the bottom of the tank, and then the clear water will be at the top. The third process is filtration. Filtration is to separate solids from fluids or liquids by adding a medium through which only the fluid can pass. The fluid that passes through is called the filtrate. The separation is not complete because the solids will be contaminated with some fluid, and the filtrate will contain the fine particles. There are many different ways to do the filtration. The first one is through winnowing sieve. When water source is contaminated by wind-borne filth, such as dry leaves, this type of filtration is best utilized. However, this method cannot be used when the raw water is highly turbid or muddy, since the sieve cannot filter fine suspended particles in raw water. We can also see from this picture, this man is actually holding a winnowing sieve, and the holes in the sieve is very small. So if it's very turbid or very muddy, then those holes will be blocked by the mud, and then it can't be used to do the filtration. Oh, sorry. The second one is the filtration through cloth. As we can see from the left, this is using a cloth to filter the water coming from the top and then collected at the bottom. This is the most suitable for filtration of well water, as it can only filter raw water containing impurities such as plant debris, insects, or coarse mud particles. The gist of this type of do-it-yourself filtration is that a thin white cotton cloth or a discarded garment is used as the filter medium. This is also the principle of using this cloth is also because that the cloth has very tiny little pores or holes on the in between the cloth fibers. And then I'm going to introduce you a very high-tech thing that's called live straw. As we can see from this picture, and this is called live straw. This is a straw, and it can save our life. That's why it's called live straw. As we can see from this short video, those filtering straw that you drink out of a stream, and it can remove bacteria and protozoa because it has a micron hollow fiber membrane. It can also use to do in a natural disaster situation. Okay, so the structure of those live straw is actually, first it comes a gravel to filter out larger sediments and like dirt, and then the second part is the sand or porcelain sand. It's to filter out fine impurities in organisms and particles collected in the top layer of the sand, gradually forming a biological zone to fill out bacteria, viruses, and parasites. The third one is activated carbon. Activated carbon is to remove contaminants and impurities, utilizing the chemical absorption process. And the fourth one is the cotton. Cotton can help to hold back the carbon and let the purified water through. Another filter is called granular activated carbon, or short for GAC. It's a proven option to remove certain chemicals, particularly organic chemicals, from water. GAC filters can also be used to remove chemicals that give objectionable odors or taste to water, such as hydrogen sulfate. This hydrogen sulfate has a rotten gas odor, or chlorine, like this. And in a house, we can see that it looks like this. In many houses, we use those GAC to treat all water traveling to any faucet or fixtures in a house. It removes the chemical before it can be ingested, breathed in, or absorbed by skin during washing or bathing, like this. Another filtration is called membrane filtration. This is widely used for filtering both drinking water and sewage. For drinking water, membrane filters can remove virtually all particles larger than 0.2 micrometer, including some microorganisms such as Giardia and Cryptosporidium. It's an effective form of tertiary treatment when it is desired to reuse the water for industry for limited domestic purposes or before discharging the water into a river. As I just mentioned, that it can be used both for drinking water or for sewage. For sewage is when before it's poured into a river. It's also widely used for beverage preparation, but it can't remove substances that are actually dissolved in the water, such as phosphates, nitrates, and heavy metal ions.